Hello, everyone. Uh, After a long time, I'm here to talk about some tool uh, that is used for Python code optimization. In my previous video, I talk about Cython and different type of programming language in regard of the speed and how optimized the codes are. And some of you liked it. So I decided to talk about some important tool called, as you can see in my screen, called Cython. So what is Cython? This is the Wikipedia of the Cython, and basically we can say, as it is already described, Cython is a superset of Python programming language. You can read it, but to make it short and easy for you, basically it is a tool that helps you to somehow translate a Python like code. So basically, it is purely Python with some specific small modification regarding to the variable types to C code. And it is compiled based programming language, or better say C inspired syntax extended or extension. What does it mean? As you can know, or as you know definitely, or not know, Python is interpreted programming language, which means that there is a virtual machine of Python all the time that translates the code to machine on the fly, and it's gets some resources and some time needs some time for do this translation. But in compiled based programming language, once your code is translated to machine code, and then it is already there. It is just in the instant type of code that your operating system can understand, and no need to further translation. So it is usually faster. Compiled based programming language you can name like C++, C, Rust, Go, and these programming languages. And interpreted programming languages like Ruby, Python, JavaScript, C Sharp, Java itself, because it needs virtual machine of Java to be installed on the machine as well. So, and one other concept that you must know is Cython is not a programming language itself, but as it said, it is a superset of programming language Python. So you don't need to learn any other syntax or something like this. And it is a static type, unlike the dynamically typed programming language. A static type programming language means that you have to define the variable types in your code. Unlike, for example, Python, that once you put an integer to a variable, next time you put, I don't know, for example, a text, a sentence, a NumPy array, or whatsoever. But here, what you must do is define your variable. So it helps the compiler to optimize the memory based on the needed, let's say, based on the needed memory. So these are the tricks that usually compiled based programming language do to speed up the process. And it is almost 70 years out, and usually many of the libraries that you see in Python that you, for example, just import in your code, they are usually written with Cython to somehow speed up the computationally heavy demands. So When you want to use Cython, you don't need to rewrite all the codes. You don't have to optimize all the codes. Just imagine you have a function that this specific function in your code needs a lots of calculation, for example, and it is some kind of the bottleneck that slower your code, the running your code. So you just need to, for example, compile that specific function. I'm going to show you some small examples, and then compile that with Cython, and then import it to your normal Python code. So basically, a Cython comes with a wrapper in Python that you just import it just like a normal library and use it. So there is no fear here that you have to write, I don't know, your code in different programming language, or I don't know, optimize the whole all line of your code, which even sometimes has no use because the native Python is fast enough by itself. So here we are talking about the calculation heavy, resource demanding type of functions that we want to somehow optimize with Cython. So it was a brief, let's say, introduction about the Cython. And you can read it, and there are, of course, many libraries, many tutorials, and many examples you can see. And but I'm going to just give you some brief example of this Cython. So for this, I'm going to use my Visual Studio Code and just give you some examples. As I told you, the aim here is just to optimize a specific function. So I'm going to simulate a very, just for the sake of tutorial type of scenario, but of course you can do it in many more complex tasks, and start with a, let's say, a simple function. Okay, and first I'm going to write it in a normal word, and then I'm going to rewrite it on Cython and then import it. And then I'm going to compare the speed so we can see if at all this Cython is useful for us or no. So let's start a simple Python code. For example, I said I want to write a function which I assume that in normal Python would be slower. So let's call it a slow function dot py, and some, as I said again, some, for example, you don't have to do this for IO tasks, reading files or these things, right? Or I don't know, a library that is already very fast and is a wrapper on C++. Many of the Python libraries that you're using is already written in C or C++, and it's just a wrapper, an API over Python. So, for example, some calculation I'm going to talk about. Let's say we want to calculate sum of squares of a number, right? So let's just write a function, and I call it def sum of squares. And it gets a normal number, so I would say n, and so we are going to have a result, so result is equal to 0 at the moment, and then for I in range just n, like n, and then oops, and then this result is e plus equal, so squares I said, right? I multiply to I. So I'm going to, for example, you put 10, it's going to sum the square all the numbers smaller than that 10, and we could have then a result. This is just arbitrary, but of course I'm going to put a more like a bigger number to see the difference. So technically we are going to do something very simple, sum of the squares. And then this function going to obviously return the results. So let's just put a comment, and this is our slow function. So far nothing new, correct? Let me just save it for myself. Now let's go and see if I want to write the similar thing, and but this time in Cython, what should I do and how should I, let's say, take care of it? So before everything, you have to install the package. So pip install Cython, right? Pretty simple. So if I just press and install it, of course in my case it is already installed. In your case it might take a bit longer. Okay. So yeah, it is installed, for example. Now I'm going to write this time, call it, for example, because this is my assumption, fast function, for example. Fast function. But this time, it is not .py. For Cython, you put pi x, right? So this is the like type of thing that the Cython wrapper will understand. So this is now pi x. So not many things are going to change here. Basically, I am going to just copy this code, just not to waste your time. And this time, let me just change the name of the function because I'm going to import both of them in one main Python file. So just to differentiate between them, for example, this brief for the site. And one thing that is important here, as I told you, we want maybe a bit bigger. You might say, okay, this is small. So now, as you can see here, it is pretty just like before. But I told you that for Cython, you have to have the type of the variable, meaning this superset of Python is static typed, meaning the variables, each variables at the time of compilation should be known that what type of data is going to come inside. So you can just search Cython variable types, and you can see, for example, for integer you have int, you have long for longer numbers, you have float, you have, and so on. So it is simple, just you can see all the list in the documentation. At the moment, I wanted to have I want to have the assumption that I'm going to have a very long and big number because I'm going to send a big number here. So one of the longest type in C is unsigned long n. So basically we are saying that I'm going to, like the Cython at the time of compilation knows that I'm going to have a very big memory size, and I'm going to put a number inside that, which you don't do it for Python because at the time of running it will be assigned to the code. Okay, and here for every number that for every variable that I'm going to use, I have to define its code. Now an important key here comes, and it's called cdef, means defining the type in C. So unsigned long for, let's say, I, and you can even put like just simple long. I just wanted to grab all the biggest number possible. Just check and choose based on your need. If your number is not going to be very big, then you might need a smaller things like just pure int, let's say, or just a long or float or whatever. Then cdef onside long this time, of course, for result. So far so good. And then I'm going to put the result 0 in the beginning instead of here. Let me grab it, and everything else is the same. So it is important to define the variable types. Okay. So far so good. Now, this is pi x and this is normal pi. What I must do to be able now have this assumption that I'm going to import this and this in a main file. Let me just create my main file first, main.py. Yes, I can here import, for example, I can import my from a slow function, import what was the name, sum of squares. Yeah. But now I cannot do this for this Cython file. Before everything, I have to compile it. But how to compile it? Okay. To compile it, you have to use like a creative file, and this is called setup.py. And in that one, we are going to use setup tools, which is a Python library. Usually comes with the standard Python, but in some versions might not. But if it was not, you just install it. Now, don't get confused. Just let me create a setup file. And the aim for this setup file is just to be able to compile the Cython. So I would put from setup tools, import setup. Maybe you see this library when you are using pip and you are getting some new libraries, and it automatically runs this for you because that library might be on Cython as well. And then since I did already install Cython, so from Cython build import Cythonize with like a small c, not capital. And then here I define my setup. So setup would be, you see it auto-completed for me, my tab 9. No need to put name at the model. Here you put x underline module. This is just my like some variable that you have to define, and you set Cythonize, and here should be the name of the file here that you wrote already. So it would be fast function, fast function.pyx. Yeah, so let me check, no error. So yeah, so this is the predefined form that you just always can use for a specific function that you want to compile it in the Python with Cython. So now how to run it basically. Here we are going to run this setup, and this setup going to read this file and then compile it for us. For that, I will just write Python. If it's small, let me make it bigger. So yeah, Python, and then setup.py. And this means I'm going to build, sorry, ext. So it means I'm going to build my library. And in place means I'm going to have it in place to the same folder. So Python setup.py. What is going to happen? It's going to read this file, understand it from here, and it's going to build it. and it's going to have it in the same folder. So let me run it. So it goes and try to compile it. Okay, finish generating code. Now see what happened here. Here, this is the file, like a .c file, just for you to showing it. You see lots of C code, right? This is just generated within the compilation time. We have nothing to do with it. It automatically generated. But for you just to understand, now we have a C code that is then compiled to what? To this pyd file. If you are on Windows, you see pyd file. If you are on, for example, Linux, it would be .so. So basically, it's some kind of library that now we can use it in our code. It is compiled already. For example, if I click on it, it cannot be opened here because it's not a text to be open easy. So let me close it. So far, I just compiled my fast function. Even you can delete it. You no need this fast function.c. It was just created within the compiling process. Now, if I go to my main file, here I can then import my compiled function. So from this time, fast function, then import, not functions, its name was function, and here sum of squares.cy. Basically here, this one. And now I told you I want to just compare the speed of these two, right? So let me import time as well. Import time. And now I'm going to write a function that just get a function, wants this, and run it, and just compare the time of the execution, right? Just so we can see which one was faster. So let me see. So def test, for example, function, and it's going to get a function, and the n, if you remember, n was the input of this and this, basically a number. We want to test it with a number, right? To see, for example, for that number, how fast sum of squares will be calculated, for that number, how fast, and so on. So first, let me put a start, and it would be like time means the current time. Then I want to run the function and put the result in the just a variable like result. Result is equal to function. And basically, the function that I'm sending to this will be run, and the output or return of that function will be put in the result. And then now end is equal to time. So I have a time before running, I have the time after running. Now, if I'm just print, I can print the let's say result and print the time taken. So print, let's say, let me write it like this: result and results, right? Something like this. And of course, how much time it was taken. Yeah. So time taken would be the end subtracted to start. Okay. And this is our function, our test function. Now let's have a number. For example, n is equal to 100. And just to give some information, print. So our first number would be purely Python, right? So pure Python function. And something like this. And now test function with sum of square, so normal one, and this n, right? this time I'm going to do the test function, but this time sum of square cy, it was written with Cython, right? And this, so now it was a simple code. Just we are going to, again, to summarize it, we are going to compare the speed of purely Python code and compiled version of it with Cython. So now just let me clear the cmd, save everything, and then run the main code. So python main.py. As you can see here, it says both took 0.0. So I can say the difference, of course, is not noticeable. So let me put let's say, a bigger number, like, I don't know, like 10 million. Or how many? 10 million. Yeah, this is 1 million, now 10 million. Okay. Because, Python, pure Python is fast for a number like 100. Let me clear everything here and now run it. Okay. So, as you can see here, time taken here was this, and the time took here is this. So you can see this one that was compiled was way faster, and the calculation took very, very in short of like 0.001, 0.3. But you might say, why the result is different, right? Probably the reason here is due to overflow, because I gave a very, very big number, and even this unsigned long cannot handle it. So let me just put a smaller number to see clear. Yeah, as you can see now, both results are similar. You already saw, but this time take 0.0.3 and something, and this one is 0.000 then 9. So you can see the one that was compiled with Cython was way more faster. But in previous case, if you remember, the number was very big, right? And because of that, this fixed amount of memory couldn't handle it. So you have to take care of it as well. You have to, for example, if your number is small, okay, take just int, take just long or float. If very big, it's long, or even you can go for bigger amount of number memory as well. You can see all of them in just in this Cython. You can just Google Cython variable types with cdef, and then you can choose the correct one. But as you can see in our case, usually, of course, you don't need such a big numbers, but in case, just you just have to take care of it. So as you can see that here, using Cython, we were able to have do a very big reduction in time. But one other thing that is important for you is always do the profiling for your code. Profiling in Python, there are many various methods. Maybe I made a tutorial about it later, about Python profiling. You can do it with memory, you can do it with just the running time of the function, and so on, and to find the bottlenecks of your codes. And if I want to just show you what do I mean by Python profiling, I will just make a simple Python profiling, let's say, code, and then you can see how you can see and check a function about how many times it is being called by operating system. So we are going to go lower levels now, and you can see analyze your Python. So as you can see, programming is not just about running a code. Okay, ChatGPT can do it and whatever. Sometimes you have to optimize your code in very low level, even though Python is not C. But you can see here, even we just made a wrapper, and technically, this function is a C function, right? And we load it within the Python. I'm just going to tell that even with Python, you can reach very, very low level of the coding as well. You have to define the time that write functions. For example, it's going to do a huge calculation and then check it. But back to my previous sentence. How to do profiling in Python? Very simple. I'm going to just show you a simple profiling Python. For example, let's say code to profile.py, right? So I'm going to just have a simple function. So if I just put like def function to profile, right? And just gets nothing. Just do something simple. For example, just do some summation, right? So total is equal to 0. Then for I in range, I don't know, some big number, whatever, right? And I'm going to do total plus I. So I'm just doing a simple summation and return total. Yeah. If you see, I have this autocomplete. If you use this VS Code, you can just add this extension called tab9, and this tab9 here, I have it, and it's like some AI based auto. Let's say complete, which just a hint, as you can see here, sometimes mine is getting, so it learns your style of coding and so on. So it is very cool, and I like it. So it's like a speed of your process. Okay, back to the code. So this is, let's say, a function. It can be a function among lots of functions. Now I'm going to do a profiling. You can, as I said, I might make some profiling tutorial as well in future, but let's see. There are various libraries, various methods, and various aspects of the code that you can do the profiling on. But a simple one that is using a library called cprofile. So I just have to import cprofile, yeah, like this, and the library of pstat to just have the status of the profiling. So import cprofile, no, pstats. Yeah, I'm going to use this for the profiling and this for showing the statistics of the profiling. So now how to use it. So if I just root cprofile.run, then here I put the name of my function in the quotation, right? For example, function to profile. Yeah, it's the name of the function, and also with the parentheses in the quotation, as you can see. You put the name here, and then you want to save it to as a status. So here I would say, for example, profile stats, right? So basically this function is going to be profile and going to go here. Now, how to show it? So I will put basically analyzing the results. So I will put like p is equal to p stats. Now I'm going to use this library stats. The status here. So I'm just going to copy paste it. So basically you can just see the logic. And now I'm going to sort the data that is already here in the p. So I put it in the p variable. Now I'm going to sort the stats. It has different parameters, but I'm going to just go cumulative. So cumulative. And so basically I'm going to sort the status based on the total time, cumulative time taken in the function calls. So I will explain it to you easier. So also print stats. Yeah. Amount would be 10. Yeah. Okay. Now I'm going to just run this code. So if I just write Python, let me clear the screen, clear. Now if I'm just, so basically what I did is using this profiler, I run this function, put everything using these stats, and then I'm going just to show the stats and sort it so I can understand how much time it was taken. So if I just run Python code to profile, okay, I have some errors. So one thing is okay, but what part? Run function to profile. Okay, I have, I think, no need to put this here. Now let me clear. Okay, as you can see here, I have total 4 function call, and it took 2.5 seconds. Why 4 function call? Because it's not just about this function. Once the Python interpreter itself goes through whole, and then at the virtual machine level. And this part here, as you can see, this is the profiler itself, function to profile. And you can see it took this amount of time. So basically you can see, even you can get a lot of more data here as well, but you can read it. And this let's say tutorial is not about the profiling itself. It's just for you to know there is something called profiling, that you can analyze your code, find the bottleneck, and try to optimize those bottlenecks. So here, as you can see, we profile out a function, sample function, that I understood that it took this amount of time. And if I have, for example, multiple function, I can go through them and understand this is the bottleneck, or that one is the bottleneck, and so on. And even it gives me more information. You can do it with the even memory profiling and so on. So basically that was it. I wanted to have a short, let's say, tutorial, but I don't know how many minutes it took. But anyway, so basically this is another way you can optimize your code. And it is not always about your code to run without people like taking care of how optimize their code is, or how they can improve the code. Sometimes your code is very resource demanding in time of calculations, and you're losing a lot of time in calculation. And that times you have the option to use, for example, such things like Cython, and benefit the advantages of C programming language, which is speed, and without going through the difficulties or too much technicalities that C have. So it gives you best of both worlds, let's say. So that's it. For me, it's enough if I gave you some hints that you just understand that such a thing exists, and go more with the more details based on your need. Take care, and see you soon.